Hi girls. Okay, so this is the third video. Now this focuses a little bit more on the first area that we were talking about, which is how do you actually get a rocket to get into space. Well, the first thing that you're going to have to do is you're going to have to build your rocket. You're going to have to design it and make sure that it has enough velocity that to get up into space. It has enough fuel to bring it up, and that it's not too big, because if it's too big, that means you're going to need more fuel and everything like that. Okay, so there is actually an equation for this, believe it or not, and strangely enough, it's called the rocket equation. That's what they actually call it. Now, lots of scary stuff in here, but it's actually really straightforward if you follow it. Okay, so I'm going to explain it as simply as I can, and it's more important at this stage that you just kind of have a basic understanding of it, and then we can really flesh it out more as you get stuck into it. Okay, so this dude here, delta. Okay, if you can remember what delta was, delta is change in. Okay, change in. V, velocity, okay, is equal to velocity of E. In this case, E is the exhaust. ln, natural log, ooh, really scary. We'll come back to him in a second. Over the mass 0, or multiplied by mass 0 over mass 1. Now, I'm sure you're looking at that and saying, what does that mean? Okay, let's deal with this first of all. Okay, so we want the rocket to lift off. Here's the rocket, okay? So we want it to change its velocity. Change velocity. Okay, so we want it to go from having no velocity to going and having lots of velocity. So that's what we're looking for, the change of velocity of. VE is the velocity of the exhaust. What that means is you're going to have the rocket, okay, and out of the bottom of the rocket, you're going to have loads of fuel coming out, okay. Now, the rate at which the fuel comes out, how much fuel you can push out as quickly as possible, is going to change the velocity. Okay, so if you can have more fuel flying out really quick, then you know it's going to go quicker. So if you can think about a hose, and the water's coming out and it's coming out quite slowly, then you put your thumb over the end of it and it comes out really quick, so it's going to hit it with more force. Okay, and remember, this is all going back to force is equal mass times acceleration, so we won't forget about that. Okay, but that's what the velocity of the exhaust, so how quickly it can come out here. Natural log, I'll come back to that in a second. Mass 0, this is to do with time. Okay, so the mass 0, sometimes this is called the wet mass, but basically what it means is the amount of or how heavy or how big the rocket is, how much mass is in the rocket when it's on the ground, when it's full of fuel. Okay, so this is both the rocket and all of the fuel that's inside the rocket. Okay, and then M1 is when it's just the rocket, when there's no fuel left. Okay, so that's all it is. So this is when it's full of fuel, and this is when it has no fuel left, and it's just the rocket. Okay, now natural log here, ln, okay, that is a logarithm, and basically that relates to time. Okay, now that is you can punch that in the calculator, and we don't need to get into exactly what that is, but basically it's you know, the amount of time it takes to get to. So if you need to get to this point here, how much time it takes, that's what ln is. So if we go back over this again, we want to change the velocity of the rocket. Okay, so the velocity of the rocket is equal to how quickly you can dispel out the fuel, but also you need to be aware of how much time it's going to take between it being full and having no fuel. Okay, because if you haven't reached this point here, so if this is you know, the rocket beginning to orbit, if you run out of fuel here, then it's just going to, instead of getting to here, it's just going to fall back to Earth, isn't it? Or if you have, you know, if it's going to run out of fuel way up here, then it's going to be too heavy, and it, you know, you might need to reduce the amount of fuel. So you use this to decide a number of things. You use it to decide how much fuel you have. Okay, if you use it to, you know, how big the opening for your exhaust has to be. If it's, you know, if you're not generating enough force, well then you might need a bigger opening, or you might need a more powerful way of pushing out the fuel. Okay, so you can use this equation to build your rocket, and you can use this equation to work out the different sizes of things, and you know, to create a prototype. And then, you know, if the prototype doesn't work, if it runs out of fuel or whatever, then you can say, well, maybe we need to increase the size of the opening for the exhaust. Maybe we need more fuel, simply, whatever the case may be. You can also use this equation to work out a relationship between gravity and the weight of the rocket, and the velocity of the rocket. Possibly you could make a rocket that doesn't fly up in the air, but does lift off the ground enough that it hovers for a certain amount of time. That might be cool. So this is the rocket equation, okay? I'll write it out once more. Delta V, so the change in the velocity, is equal to the velocity of the exhaust, ln, which is the time it takes between when it's full of fuel and when it's empty. Okay, that's the rocket equation there. Okay, thanks guys.